All right, so now we're going to see what it looks like when we solve a system of equations when we don't have both equations starting with a y equals. So not all equations start with y equals. That's what we've been working with up until this point mostly, but they're not always going to start with y equals. So how do we solve a system of equations that doesn't start with y equals? Okay. First of all, you won't be able to graph them because the only way that you can graph, not the only way, but the only way we know how to graph a equation of a line is if it's written in this y equals mx plus b form. So starting with the y, right? The m is the slope, the b is the y-intercept. But again, lines are not always written this way. So take a look at our exercise number 2. If you look at what I've just highlighted here, we have the equation x plus y equals 14. Now, does that mean that this is not a line because it's not written in y equals? No, okay? This is a line, and it could be written in y equals if we needed it to. If I just subtracted x on both sides, okay? If I subtracted x on both sides, I would get an equation that looked like y equals, see, these would cancel out the x's, right? Okay, there wouldn't be anything to actually subtract the x by over on this right side, so the x would just come over here to the right side, negative x, and then plus 14. So this actually would be y equals negative x plus 14, and that would be easy to graph. But we're not going to do that. What we are going to do is another form of substitution method. So you guys, at first, I gave you what the solution actually is. We're going to work backwards a little bit, and I said show that the solution to that it is a solution. So what you guys have done is you've taken the x value and you plugged it in where you saw the x, and you take the y value and plugged it in where you saw the y into both equations. Same thing to this one here too. Took the x, put it there, took the y, put it there, okay? And what you did was you simplified using your order of operations to get to the end, making sure the right side equals the left side. So we were doing that last lesson as well, a little bit of a review. But now I want to take that same idea and I want to actually solve this system of equations without knowing the solution, even though we do know the solution is going to end up being 410. Let's solve it algebraically and get to that answer of 410. How do we get it? Well, again, we're going to use a form of substitution. So usually when we did substitution method, we would highlight or circle this y equals to note that this equation tells me that y equals this stuff, right? And I would usually circle this. And then on the other equation, it would be the same. I would highlight the y and circle what the y equals. In this first equation, though, we don't have a y equals something, okay? But we do have a y, and so we're going to use substitution methods similar to the way we substitute in a number in for a variable. I'm going to take this expression here, this 3x minus 2, that they're telling us y equals, and I'm going to substitute that whole thing into this first equation where it says y. And the reason why I can do that is because, again, this is telling me y equals this stuff. So in this equation, I can replace, just like a substitute teacher replaces the main teacher, right? I'm taking this 3x minus 2 and I'm substituting it in to this first equation. Now, why would I do that? This is going to make it look even more complicated than you are, looking for, right? Looking for easier. This looks kind of complicated. First of all, why did I put in parentheses? Remember, anytime we substitute something into an equation or in for a variable, we put it in parentheses. Now, again, why did I do this? Well, now we have an equation that only has one variable. If it only has one variable, only has x, I can actually find what that x is using my algebra skills from the beginning of the year. If it's two variables, I can't solve it, okay? But if it's one variable, I can. There's just x. Now, there's multiple terms with an x, but there's just x, okay? So we're going to solve this. It's going to have to bring back some ideas that we learned from the first unit that we haven't really looked at in a while. First of all, if I have a plus right next to parentheses, that means I can drop those parentheses. They're not necessary anymore because I don't need to group them. We know that you can move around the order of addition at all, so we don't need the grouping symbols if I can move around the order, okay? So those parentheses get dropped, and now I'm left with this expression. Now, I do have two variable terms. We've been talking about when variable terms are on opposite sides, we get rid of one of them. If they're on the same side, if you recall, we actually combine like terms. And the reason why we do that is because I only want one x term. Again, we talked about that in the previous lesson. I only want one x term. Right now I have two of them, but they're on the same side. If they're on the same side, I combine like terms, which means add. So x and 3x gives me 4x. Okay, I still have my minus 2. Okay, and that equals 14 still. And now I am finally into my two-step equation. At this point, hopefully we're getting pretty good at this again, reminding ourselves of how to do this. We always do the opposite. Okay, so I'm adding 2 to both sides to get rid of this negative 2. All right, I am bringing down the 4x because I have not used it in that step. Okay, 14 plus 2 gives me 16. And now my last step here is going to be divide by the number that is next to the variable. So in this case, that's a 4. I'm dividing by 4 on both sides to keep the equation balanced. And that gives me an x equal to 4. So I found that x was equal to 4. We already knew that was the case based on the previous, but that's great. So now what we're going to do is we need to find y. Okay, we need to find y. How are we going to find it? Well, usually we plug it into one of the equations, right? And usually we pick the first one just because why not, right? But in this case, it's actually going to be easier to choose the one that starts off with y equals. And the reason why is because I need to find what y equals. So I know what x equals. If I can put it into this equation and simplify it, then I'll get what y equals. In this case, I don't have a y equals something. So if I put it in for x here, I'm still going to have some manipulation to do that might be a little bit challenging. So my suggestion is to choose the equation that starts off with y equals when you're trying to find what y equals. So I'm taking this 4 for x, I'm replacing the x with it. So I now have y equals 3, parentheses pocket, 4 minus 2. And I'm simplifying. We've been doing this for a little bit now. Hopefully you guys feel pretty confident in finishing this out here. We have 12 minus 2, which we know is 10. And that got us our solution, which we originally had gotten from the previous section that you guys worked on. Okay, so our solution here is 410. Okay, I'll see you guys in the next video.